Good day, students. Today we are going to talk about electrolysis of concentrated aqueous sodium chloride. It's also called the brine. Okay, so we just want to account for the observation that when electrolysis of brine is taking place, we are going to have bubbles being evolved at both electrodes. And then as people studying electrolysis, it is our job to actually identify what gases are being evolved at each of these electrodes. Because apparently when this electrolysis takes place, at both the anode and the cathode, there is this evolution of gases, okay? Right, so electrolysis of concentrated aqueous sodium chloride is a bit more complex than electrolysis of molten lead to bromide, for instance, because now we have aqueous, the aqueous part in sodium chloride, meaning to say the sodium chloride is mixed with water. So we have a set of 4 ions that are present here. Sodium and chloride, these ones are from the brine, okay? But H plus and OH, these ones are coming from water, okay? Right, we have 1, 2, 3, 4 ions that are present. But in electrolysis, we discharge only 2 because we have 2 electrodes. So we need to exercise what we call selective discharge of ions here, okay? You need to remember that selective discharge of ions is affected by a number of factors, like the relative position of ions in the electrochemical series, the relative concentration of the ions, even the nature of electrodes, okay? In this one, we're going to be using inert electrodes. Those ones, those electrodes which are not going to take part in the electrolysis process, such as platinum or graphite, okay? Right, so let's look at what happens at the cathode. To start off with cathode, okay? Our cathode is negatively charged, okay? So if you look at the ions that we are given here, okay, 2 ions are going to migrate to the cathode. And which 2 ions? Okay, the Na plus and the H plus ions, both will migrate to the cathode, okay? But only one is going to be discharged, okay? Now, for this one, you need to remember what we call the reactivity series of metals, okay? Or what is known as the electrochemical series, because metals are arranged in order of decreasing activity, okay? They are arranged in order of the decreasing ease of oxidation, okay? For instance, if you look at sodium, okay, sodium tends to form ions more easily than it is reduced, okay? But in that electrochemical series, we also include hydrogen, okay? So all those metals that are above hydrogen, okay, you're going to find out that those ions or those metals would rather lose electrons than being reduced, okay? Because by the cathode, we're going to gain electrons. So if you are given any metal, okay, what you have to remember is the metal above or below hydrogen in the electrochemical series, okay? Because if it's above hydrogen, it means that metal has a tendency of forming positive ions rather than forming the atom, okay? All I'm saying here is, as we go down the electrochemical series, okay, the metals are arranged in order of decreasing reactivity or decreasing ease of oxidation. So if I'm given sodium, Na plus and H plus, okay, H plus has a tendency of being reduced, okay, more than Na plus, okay? So when these 2 ions arrive at the cathode, it's actually H plus, okay, which is going to be reduced, okay? So we'll form hydrogen, okay? Again, here, you have to balance the equation. You put a 2 there, and you put a 2 there, okay? So Na remains in solution. Given Na plus and H plus, okay, you have to remember that they are metals that are above hydrogen. Those metals, okay, have a tendency of forming positive ions more than hydrogen, okay? So if you are given hydrogen and Na as elements, for instance, okay, sodium, okay, would form an ion easily than hydrogen. So if you have the corresponding ions, Na plus and H plus, the H plus ion will have a greater tendency to be reduced. So it is selectively discharged because of that. Okay, right. So the H plus ion is actually going to be discharged, and by the cathode we are going to have hydrogen gas. Okay, now let's look at the anode. Okay, the anode. Now again, the anode is positively charged. Okay, the anode is positively charged, and two ions are going to migrate to the anode. Okay, now you have the chloride and the OH minus. Right. This one at A level, you'll be given what are called electrode potential, where you'll be having values. But for IG, okay, for the extended part, what you simply have to remember is for the discharge, the selective discharge of these anions is chloride or the halide ions. They tend to be discharged, okay, if they are present with sulfate ions, with OH minus ions, okay, even with nitrate ions, okay. The halide ions are discharged more easily than the hydroxide, the sulfate, and so forth. This you have to remember. When you come to A level, you'll be given a data booklet where you are supposed to predict using what are called electrode potential. So for this one, it's the chloride, okay, which is going to be discharged. So here you can say minus an electron, okay, and then you form chlorine, okay, right? It's 2 here, so you have to balance your equation. Either you write it like this, or you write 2Cl minus, you put an arrow, chlorine plus 2 electrons. Okay, then you have a gas. All right, so we have actually discharged, okay, we have actually discharged our chloride and H plus. All right, now do you see what is going to happen? This one is gone, and that one is gone. What remains in solution, okay, what is going to remain in solution is Na plus and OH minus, okay? Because this has been discharged, we have hydrogen by the cathode, and this one is discharged, we have chlorine by the anode. What remains in solution is sodium and hydroxyl. So our electrolyte apparently, which was concentrated aqueous sodium chloride brine at the start, by the end of the process, our electrolyte is going to have a high pH, because instead of sodium chloride, it's actually going to have sodium hydroxide, okay? So in an exam, you could be asked, okay, predict the pH of the solution after the electrolysis process. What you simply have to remember is that after the discharge of H plus ions and chloride ions, you are going to have sodium hydroxide. So you are going to have the pH, okay, and an alkaline solution, okay, is going to be produced, okay. And in addition, an additional question that you could be asked is, how do you test for the gases, okay? So whenever you are studying a topic, like I mentioned always in my videos, make sure that you interlink concepts, okay? There's a gas that is being produced. We are supposed to remember the confirmatory test that we can do to test for the presence of hydrogen, the confirmatory test that we can do to test for the presence of chlorine. I hope you still remember the popping sound for hydrogen, and also the fact that chlorine has a bleaching action on a moist litmus paper. Okay, right. So this is the explanation for the apparent observation of the fact that when we carry out electrolysis of concentrated aqueous sodium chloride, we are going to have bubbles, okay, being observed at both the cathode and the anode. This is due to the presence of hydrogen by the cathode and chlorine by the anode. Okay, right. So this was just the session today. Remember, if you like this video, please show by thumbs up that you have actually benefited from the contents of this video, and also please kindly share with your friends so that when we talk of selective discharge of ions, they will be more comfortable when they are answering questions. Bye bye for now.